This video is about using rotations to create a three-dimensional figure and identifying different parts of a three-dimensional figure. So the first three-dimensional figure that we are going to start with is a prism. So in a prism, a couple of different parts that we have. The first one is a base. So a base is a set of two congruent and parallel surfaces. So in our rectangular prism, we would have our bases are here and here. The triangular prism, the bases are here. This is another triangular prism. So notice the bases don't always have to be the top and the bottom. And in the hexagon, we have the hexagon as our bases. So these would be our bases. So the height then is the distance between the two bases. So if we go back up here, our rectangular prism, this would be one of the sides that would represent our height. This would be one of the sides that represents the height. Here, because the bases are going from front to back, this is actually going to represent the height. So it's not always going to go from bottom to top. It could go from back to front or from left to right, depending on how our shape is laying. The hexagon, any of these edges that are between the bases would also represent the height. So a face then is a flat polygonal surface. So any of these sides of our shapes would be a face. The edge is a line where two faces intersect. So like where the heights are, that would also be considered one of the edges. And then the vertice is a point where three or more edges intersect. So let's look at some different prisms and answer the following questions. So in number one, what is the shape of our base? Well, if the base, because it's a rectangular prism, we can just use the one on the top and the bottom. So our base is the shape of a rectangle. What is the height of the prism? So if our base is the top and bottom sides, our height is the distance between it. So our height would be 2 inches. What is the perimeter of the base? So if we said the base was a rectangle, we see that there's one side that's 5 and one side that's 11, which really means in a rectangle, two sides are 5 and two sides are 11. So we have 11 plus 5 plus 11 plus 5, which gets us 26 inches. To get the area of the base, because it's a rectangle, it's base area times height, or base times height, so it'd be 11 times 5, which would be 55 inches squared. In number two, when we look at our figure, the two shapes that are the same are going to be these triangles. So our base shape is going to be a triangle. The height then is going to be the distance between the two bases. So our height here is going to be 12 meters. The perimeter of our triangle, we only have two sides. So perimeter, we have to find the third side by doing Pythagorean theorem. So x squared equals 3 squared plus 4 squared. X squared equals 25, so x is 5. So if we know that side's 5, for our perimeter, we'd have 3 plus 4 plus 5, which would give us a perimeter of 12 meters. To get the area of the base, because it's a triangle, the area is 1/2. 1/2 times 4 times 3 will get us 6 meters squared. In number 3, if we look at our shape, our base is going to be a trapezoid. So we have the trapezoid that's in the front up here and in the back. So our base is a trapezoid. The height of the prism, remember, is the distance between the two bases. So our height would be 11 centimeters. For our perimeter, it's an isosceles trapezoid that has the sides of 10, 21, 10, and 9. So our perimeter would be 10 plus 21 plus 10 plus 9, which would get us 50 centimeters. And then to get the area of the base, it is 1/2 the base 1 plus base 2 times the height. So we would have 1/2. Our bases are going to be 21 and 9, and our height is 8. Make sure when you're using height here, we're talking about the height of the trapezoid. So when we multiply, we would have 1/2 times 30 times 8, which would be 120 centimeters squared. So our next shape then is a pyramid. So a pyramid is going to have only one base, and then it's going to have come to a tip at the other side, which would be the vertex. So our base edges are the sides of the base. So down here, this would be a base edge. The lateral edges then are the edges where the lateral faces meet. So this part right here, this would be a lateral edge. Then we have the slant height. So the slant height, which when we get to our equations is going to be abbreviated as a cursive L, is the height from the vertex to the base edge. So it's going to be on the side of the triangle. Think of the slant height as like if you're sliding down the side of the pyramid. This is going to be our slant height, which means our altitude or our height, which we're going to abbreviate as H, is going to be the height from the vertex to the center of the base. So this would be our height, which we could also call the altitude. So in number 4, we want to find the slant height and the altitude. So to find the slant height, we're going to split in half because this is in half. We're going to use Pythagorean theorem to get our slant height. So we have 13 squared equals 5 squared plus x squared. 169 equals 25 plus x squared. 144 equals x squared. So x is 12. So our slant height is going to be 12. Then to find our regular height, we are going to draw in bottom of the triangle. That length is also going to be 5 because it's half of the base side still. So we would have 12 squared equals 5 squared plus y squared. 144 equals 25 plus y squared. We can subtract 25 and we get 119 equals y squared. So when we solve, y is the square root of 119. That is going to be our height. So number 5, we're going to use the figure to answer the following questions. It's asking for the height and the slant height. So we're actually going to skip down and we're going to do the slant height first. So if I want the slant height, I need to use this triangle to find our slant height. And we know that the side is bisected, so 6 splits into 3 and 3. So to find our slant height, we would have 5 squared equals 3 squared plus x squared. 25 equals 9 plus x squared. X squared equals 16. So x is 4. So our slant height would be 4 centimeters. And we need to do that first because that's going to help us to find the height, because we're going to use the triangle now that's inside with the slant height. So again, it was bisected 6. That bottom part of the triangle is 3. So for our height, we would have 4 squared equals 3 squared plus x squared. 16 equals 9 plus x squared. 7 equals x squared. So x is the square root of 7. So our height would be root 7 centimeters. What shape is our lateral faces? Well, the lateral faces are the shapes that are not the base, which means that they are going to be a triangle. Our base then, because it's a 6 by 6, that is going to be a square because all the sides would be congruent then. So to get the perimeter, there are 4 sides that each have a side length of 6. So our perimeter would be 24 centimeters. Our area, to get the area of a square, is side times side, which would be 36 centimeters squared. Our next figure then is a cylinder. So a cylinder is like a prism, except for that the bases are always going to be the same. So the base are going to be two congruent and parallel circles. So here would be a base, and here would be a base. Just like in a prism, our height is going to be the distance between the two bases. So for here, if the bases are up and down, the height would be going up and down. If the bases are on the left and right, the height would be going side to side. Then the lateral face, if we were to take a cylinder, think about like a soup can. If you were to take the label off of a soup can and lay it out, it's going to give you a rectangle. So our lateral face is a rectangle that is wrapped around. So in number 6, what is the shape of the base? So the shape of the base is a circle. What is the height? Well, the height's the distance between the two bases. So the height would be 13 inches. What is the perimeter of the base? Well, because the base is a circle, your perimeter is going to be the circumference. So our perimeter is 2 pi times 4, which would get us 8 pi inches. The area of the base then is the area of the circle, which is pi r squared, so pi 4 squared, which would be 16 pi inches squared. Shape then is a cone. So a cone is very similar to a pyramid. The only difference is that it has to always have a circular base. So our base of a cone is always going to be a circle. So down here, this would be our base. The slant height is just like in a pyramid. It's still going to be used the cursive L. It is the height from the vertex to the circle edge. So this here would be our slant height, and then our altitude or height would be the height from the vertex to the center of the base. So this would be our height, which is always an H still. So in number 7, what shape is our base? Well, our base is a circle. What is the slant height? So they already gave us the slant height. The slant height is going to be 17 inches. What is the height? So we have to do Pythagorean theorem to get the height. So we have 17 squared equals 8 squared plus x squared. 289 is equal to 64 plus x squared. 225 is equal to x squared. So x is 15. So our height would be 15 inches. What is the perimeter of the base? So the perimeter of the base, remember, is our circumference, so 2 pi times 8, which would be 16 pi inches. And the area of our base is pi 8 squared, which would be 64 pi inches squared. The last thing we're going to talk about then is what happens when we rotate a solid that's a two-dimensional shape around a line called the line of symmetry or the line of rotation. So if this happens, if we take this and we rotate in a circle, we have just created a cylinder. So anytime that there is a rectangle or a square and we rotate around, it's going to create a cylinder. In number 2, if we rotate a triangle around, we get a circle on the bottom. We can bring our side over here. That's going to create a cone. So anytime that there is a triangle, there's going to be a cone. And in number 3 then, we have this half circle, and every time we move a half circle around, it's going to create a circle going all directions. So it would look something like this. And this would be a sphere.